All right, guys. So this problem asks you to take a look at the structures provided and determine the molecular formulas, the empirical formulas, and to sort out if there are any isomers in the structures that you get. So in order to get this together, you need to have three definitions down. The three definitions that you need are the one for molecular formula. Remember, the molecular formula is simply, it's a list of all of the elements that are present in the molecule and how many of each element there are. And so it's simply a list of the types and numbers of elements. However, the empirical formula is just a little bit different. It's the lowest whole number ratio of elements in the compound. So it's the lowest whole number ratio of elements. The last definition that you need to be able to sort out is the definition for isomer. And isomers have the same molecular formula, but they have different shapes, or another way to say that is different structures. So in other words, it's got the same formula, but it's shaped differently. And so in order to figure out isomers, you can see the shapes, so we visually can inspect that. So we just need to look at the molecular formulas. Clearly, all four of these have different shapes. So we need to sort out if whether or not there are any of them that have the same formula. And if they have the same molecular formula, then we'll know that they're isomers. So let's go ahead and sort them out. So in order to figure out the molecular formula, you have to count the number of each element. So in the first one, we've got carbons, we've got hydrogens, and we've got nitrogens. There are, if we count, we got 5 carbons, we count 13 hydrogens, and there is 1 nitrogen. Remember, we don't show the 1. In the next one, I've got carbons, hydrogens, and oxygens. If I count the carbons, I have 4. If I count the hydrogens, I have 10. And if I count the oxygens, I have 2. So C4H10O2 is the molecular formula there. In the next one, I've got carbons, hydrogens, and oxygens, just like before. In this case, I have 3 carbons, 6 hydrogens, and 2 oxygens. In the last one, I've got, again, carbon, hydrogens, and oxygens. And counting them all up, I find that I have 4 carbons, I've got 10 hydrogens, and 2 oxygens from the picture. And so I literally am just counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. And then I'm counting 1, 2, 3 carbons, and then I'm counting 1, 2 oxygens. And so you do that for all of the different formulas that are, or structures that are there. Now, look at what we have here. We've got this one and this one as having the same molecular structure, but they're different shapes, or they have the same molecular formula, but they have different molecular structures. So let me go back just a half second and restate that. Different structures with the same formula, they're isomers. Now let's sort out the empirical formula. The empirical formula is the lowest whole number ratio of elements. So if you can take one of these formulas and divide it by a whole number to get another set of whole numbers, then you can determine a different empirical formula. So for the first one, though, it's 5, 13, and 1 for the different atoms. So I've got 5 carbons, 13 hydrogens, and 1 nitrogen. There isn't another whole number that I can multiply that by. So that is the empirical formula. The molecular formula is also the empirical formula. But the next one is C4H10O2. All of those are divisible by 2. So in order to sort out the molecular formula, I can divide them all by 2, and I get C2H5O. That would be the empirical formula. Now, I'm going to skip over to the end. Because they're isomers, they had the same molecular formula, that means they'll also have the same empirical formula. So the second one and the fourth one will have the same empirical formula as well as molecular formula. Now let's take a look at this third one in the middle. The third one in the middle has 3 carbons, 6 hydrogens, and 2 oxygens. None of those numbers have a common divisor that we can use to get another whole number. So this one is also in its empirical formula. All right, that's it, guys. Thanks.